This project is titled SoundCells, Designing a Browser-Based Music Technology for Braille and Print Notation. I'm Willie Payne. I'm a PhD candidate in music technology at New York University. I'm a skinny white guy with short black hair and glasses wearing light, loose clothing. My co-authors are Fabiha Ahmed, Mike Gardell, Amy Hurst, and Luc Dubois. We come from a range of backgrounds, but we're all part of the Ability Project, an interdisciplinary research group at NYU that works at the intersection between disability and technology. In this talk, I'll describe the need and motivation that led to SoundCells development and share a demo. Then I'll describe how SoundCells was designed with 2 experienced blind musicians and briefly evaluated with 5 others. Finally, I'll discuss what we learned, especially pertaining to SoundCells inputs and outputs, and point to some exciting directions for future research. So music, of course, is mainly experienced through sound. However, music notations use other mediums like print or Braille. In the figure, there's one measure of music displayed 3 ways: in standard print notation, in large print, which is much bigger and uses custom fonts, spacing, and layouts, and Braille music, a standard encoding read by many blind musicians. While each of these forms of notation exists, publishers and online databases only provide music in standard PDF image formats. So the burden of acquiring the music one reads can often fall on blind musicians. Fortunately, a lot of great research and technology over the last few years has explored how to expand access to accessible music notations, especially through scanning and file conversion. However, still converting a print score to Braille can be a time-consuming and intensive process dependent on multiple pieces of software. Typically, 1 or more sighted people scan or copy a score using music notation software, export it to a standard encoding like Music XML, and convert that to Braille using a conversion script like Goodfeel or SoundMyBraille. Finally, they send it to a Braille music expert to tweak layout, improve legibility and accuracy, and make corrections. Visionability is necessary for copying the print score, while Braille expertise is necessary for finalizing the Braille score. I've worked as a transcriber for more than 2 years, helping produce scores for blind and visually impaired learners, so I'm very familiar with this workflow. More research to date has studied how to make existing scores available in Braille or large print, rather than understand the needs and workflows of blind musicians who notate new music. A lot of commercial music software is highly visual, using graphic user interfaces and what you see is what you get interactions. On the left, I'm using a mouse to add notes and drag musical symbols within the notation software Lime. On the right is the music notation view inside the digital audio workstation Logic, next to a long list of musical events. These tools and others are very complicated and can pose accessibility barriers to blind and visually impaired musicians. So this brings us to SoundCells, which I'll now present in a brief demo. SoundCells is a music notation software available for free in browsers. It uses a syntax called ABC to input notes and other musical symbols, and renders scores in both print and Braille notation in real time. The entire page is keyboard navigable and designed to be used with a screen reader. The main interface consists of a text editor, button to display the score and Braille music notation, audio playback controls, and a visual rendering of the score. On the left is a bunch of documentation to get started, including a tutorial and some example excerpts like the Mario theme you can listen to and remix. Currently, I've begun a score, named it A Nice Tune, set its meter to 4/4, and its key to B flat. I've also filled in 2 measures of music. By pressing Command-Shift-Space, we can hear them played back. Great. Let's complete this tune by adding a couple more notes and bar lines. Each of the letters I just typed, G, F, G, A, were notes. SoundCells played each one right as I typed them. Let's add our last note and a double bar line. Okay, I think I've finished this phrase, but I see a yellow underline below the fourth measure, so it looks like something is wrong. If I hover over the measure, it tells me it's underfilled, meaning it's not long enough. I can also press Command-Shift-M to open a diagnostics list that can be navigated with a keyboard. I'll fix this by adding a quarter note rest to the end. Okay, let's play the whole thing back. Sounds good. By pressing Command-Shift-9, I can display the Braille music. While focused with an external Braille display connected, a user can navigate the Braille music score line by line. There's also a settings menu where I can change some properties of the music. For example, if we wanted to make a large print version of the score, we might increase the size of the notation and also change the paper orientation and size to be landscape and 11 by 17 or A3. Finally, when we're ready, we can download the score. SoundCells supports a few different file types. An ABC text file can be easily shared, for example, copied into a body of an email. A Braille file can be embossed, a PDF can be printed, and a music XML file can be opened in virtually any other music notation software, meaning projects started in SoundCells can be continued in other commercial tools. So I'll click download, and I'll drag into view our new print score, a nice tune. We co-designed SoundCells with two blind musicians, one an expert in Braille music and the other familiar with a wide range of music software. In the first meeting, they tried an early prototype that converted ABC text to Braille music, and they expressed interest in pursuing the concept. The results of this first meeting are shared in a poster at Assets. The latter three meetings, held remotely over 2 months, were loosely guided by recent additions to the interface and were wide-ranging. A lot of this work was also done asynchronously. The co-designers tried SoundCells on their own and shared ideas. From co-design, we determined the layout of the interface and the available keyboard shortcuts for navigation and for querying text-to-speech feedback. Following co-design, we conducted a remote design probe with 5 other blind musicians, resembling the first co-design meeting. Most were less familiar with music technology, and some had never used music notation software before. Each session included a 30-minute guided exploration of SoundCells in which participants learned to write notes and simple rhythms and were tasked with completing a short recognizable tune. Then we asked participants to describe their experience, reflect on whether or how it may fit into their workflows, and brainstorm potential improvements and features. All co-designers and participants expressed enthusiasm about SoundCells. Many especially liked how it played back the music as they typed. All were able to independently compose a short, simple tune with just a little bit of instruction. We organize our findings into 3 themes: text input, multimodal output, and interface accessibility. First, we saw a striking difference between co-designers and participants in how they engaged with text. In the first co-design meeting, each expert improvised and wrote new material. Participants, in contrast, stuck to getting their tune to sound correct. In general, co-designers expressed little concern about learning and memorizing syntax, wanting support for as much notation as possible, while participants felt syntax could get confusing and suggested UI features for aiding the editing process, like a symbol selector menu. These contrasting experiences suggest that going forward, we may need to balance designs that lower the floor for novices while raising the ceiling for experts. Second, participants used a combination of outputs, including music, text-to-speech, and Braille for feedback as they edited. On multiple occasions, we witnessed a participant detect a mistake through hearing the music or feeling the Braille score. We also saw a range of assistive technology setups being used. For example, some participants only used screen readers, while one co-designer used a Braille display with audio often disabled. Thus, we need to ensure that SoundCells is accessible regardless of the assistive technology available, but also ensure that if multiple output modalities are available, they support rather than clash with each other. Finally, participants appreciated how simple the website was to navigate and found the interface accessible and intuitive, but there were some issues. The coding editor we used introduced a significant bug for voiceover users that was not detected earlier because our co-designers used JAWS and NVDA. Additionally, some participants tried SoundCells on mobile devices and Braille displays and reported mixed results. Because input in SoundCells centers around the QWERTY keyboard, support for other platforms would require significant design consideration. While research to date validates the SoundCells concept, participants have largely engaged with it through short guided activities. To further explore the design of text input and multimodal outputs, we intend to deploy SoundCells in a much longer study where participants compose their own music. Additionally, we found through co-design that a major benefit of text was how easy it made sharing music, especially works in progress, over email. We'd like to explore how SoundCells is used in collaboration, especially to support mixed vision environments in which musicians all read their own forms of notation. So thank you so much for your time. You can try SoundCells at soundcells.herokuapp.com. I'd like to thank the Ability Project, Vertically Integrated Projects, and the Philemon M. D'Agostino Greenberg Music School for their ongoing support.